In this demonstration, you'll learn how ANSYS Polyflow software can help you minimize your material costs for blow molding applications, while maintaining the thickness distribution you need in your final product. Presented here are the results of two Polyflow simulations, shown side by side. They both simulate the blow molding process of a polycarbonate water cooler bottle. They begin with a cylindrical parison, which over the course of the simulation will be pinched off by a moving mold and then inflated to take the final shape. On the right is an initial design for the parison that has a constant thickness of 4 mm throughout. On the left is a parison that has benefited from Polyflow's parison programming feature. Polyflow can predict where the initial thickness can be reduced without compromising the final product. The parison programming feature provides an answer to the following question. What should the initial thickness of the parison be to meet a targeted final thickness? In theory, this question may be asked for each point on the part, but for practical purposes, it's typical to target only key points on the final part, and to divide the parison into sections, or stripes, that initially have a constant thickness throughout the cross-section. The colored contours here indicate how the thickness changes. The red regions are 4 mm thick like the original parison, but for the most part, the rest of the parison is reduced to between 2.5 to 3 mm thick. I can then validate the optimized parison by running the two simulations. As you can see, the optimized case has a substantial reduction of material in the flash, that is, the plastic that lies outside the mold that will be trimmed and then recycled. While the flash may have changed, it's clear that elsewhere the optimized design has a material distribution that's very similar to the original design. This means that the strength of the optimized part was not affected by the reduction of the parison material. As a logical next step, you could use ANSYS Workbench to transfer the results of your optimized blow molded part to our FEA solver. There you could run simulations that use this realistic material distribution to see what stresses develop when the part's subjected to loading, such as top loads or drop tests. This concludes this demonstration of Polyflow's parison programming feature for optimizing blow molded thickness. It's just one of the many ways ANSYS helps you realize your product promise.